Right, in this video I'm going to go through how to analyze a set of data. So here's a set of raw data that I've collected for an Ohm's law experiment. So basically what I did was I connected a resistor to a voltage source and I applied 8 different voltages, and then I recorded the current with an ammeter and the voltage with a voltmeter. So I should probably label these with the units first. So that's in amps. Okay, and then I want to estimate the uncertainty here. Well, I measured this with a voltmeter that had 1 decimal place. So it's 0.1 here because it was a digital voltmeter. And here I measured the current, and I took 3 values. So I'm going to average those. And then I'll autofill those. And I definitely didn't have it to that level of accuracy, so I'm going to reduce the number of significant figures here, because I only had 2 significant figures on the meter, and these should all be to 2 as well. Okay, so this is the average current in amps, and this is the uncertainty in voltage, in volts, and then we want the uncertainty in the current, and that's going to be equal to, and we're going to take the maximum of our 3 obtained values. We're going to subtract from that the minimum of our 3 values, and then we're going to divide that by 2. Oops. And the uncertainty should be to just 1 significant figure, which it nearly is there, except for those ones that they need to be reduced to 1. Okay, and these ones then need to be reduced to the corresponding number of significant figures. So now that all looks like it works. Okay, so there's our raw data. Maybe I should just, so what's that? 1, 2, 3, 4, 5, 6, 7 columns and 9 rows. So I'll put that into here. And rather than just copy I can try copying the Excel one, but it usually doesn't work so well copying. Oh, that worked reasonably well. I'll just leave it at that. I think there is a way to fit it. No, it doesn't auto-fit. Okay, so there's our data table, and our uncertainty and current should have a unit as well. Okay, and then here we'll put in sample calculations, and that will be how you worked out your uncertainty and how you worked out your average. What I want to focus on in this video is how we can produce our graph. So if we now go to loggerpro, and we're going to insert our data into these 2 columns. So I'll go back to here, and I'll take my data from here, take our voltages, and we'll insert those here. And then we'll take our average currents, and we'll insert those here. And then we'll label these. So the X1 is the voltage applied across resistor, V, and the units are volts. And this one will be current measured through resistor. And that has a symbol I, and that has units of amps. Done. And then we're going to need to also add 2 columns for our uncertainties. So we go to data, new manual column, and this is the uncertainty in voltage. And I'll just call it UV. And the units for that are going to be volts, and data, new manual column, uncertainty in current, UI, and that's in amps. And then we're going to get that information from our data table here. Uncertainty of the voltage is here. And the uncertainty in the current is here. And then we need to click back on our voltage column and go to Options and choose Error Bar Calculations and Use Column. And we're going to use Uncertainty in Voltage for that one. And for this one, we're going to use Error Bar Calculations, Use Column, Uncertainty in Current, which looks like that. Okay. And then what we want before we take our graph is we have to do a couple more things to get a sense of how accurate our relationship is. So first we'll autofill, and then we'll make sure that we include our origin in the graph by just clicking on the lowest number and changing it to 0. You can also drag up and down like this to make sure that you've got 0 in the bottom corner there. Okay, so there's our data. And then we want to do Analyze, and we want to choose Linear Fit for this data. And we can see that it's a reasonably good linear fit. Okay, now we want to get a sense of how much the gradient might vary. So what we're going to do is we're going to add a second linear fit by going to Curve Fit, choosing Linear, and ticking Manual. In fact, if we go back to Automatic, in fact, I'll go to Manual and I'll go Automatic and try Fit, and then switch to Manual. Then you'll get the same thing as your line of best fit. And if we double click on that, whoops, there's an option to enable line drag like this, which gives you 3 points that you can drag. And what we want with this line is we want it to be, this is going to be the biggest possible gradient that still goes through our error bars. So I'm going to kind of make it go through the top of my top data point and the bottom of the error bars of my bottom data point. So now this one just clips that bottom data point, and it just clips the error bar of that top data point. So that's my maximum error line. And then I want to add a second one that's going to be exactly the same, except this one is going to go through have the smallest possible gradient. So I'm going to stick with linear and try fit, change to manual, click OK, and there's my new one, and I'm going to double click on that, choose enable line drag, and then this one's going to go through the top of my bottom points error bars and the bottom of my top one. Oops, I just moved the wrong one. Oh, I just moved the wrong one again. Let's just go back to this one. There we go. So now that one is going through close to the bottom of this top error bar here, and close to the top of this bottom error bar. Maybe I can move it up just a little bit more, like that. And they cross somewhere near the middle. I'm just going to color code these because it's kind of confusing at the moment. So this one, I'm going to change the appearance, and I'm going to change it to red, for example. And then I'm going to change this top one, which is this one. Appearance, and I'm going to change it to blue. Okay. So now I have my maximum error line, along with all the information about the maximum error line, my minimum error line, and my line of best fit. Okay, I'm just going to shrink it down a little bit so that it pastes in correctly, because otherwise if you paste it into your document, all of the information becomes really, really small. So the reason I'm resizing it in this program rather than resizing it in the document is that once you paste it in, everything shrinks when you resize it, including all this information. So we should probably also add a title. This is current versus voltage for ohmic resistor. Done. Okay, and then I'm going to just Control-C, copy that, And then I'm going to go back into my document here and insert my graph. And my graph looks like that. Okay. So I've got all of that information there. I'll put this all on a new page. And then the next step is to obtain the equation for this. And I'm going to do that in a separate video.